Hello, dear students. Today we are going to learn the important concept curve tracing. Curve tracing. Curve tracing means the approximate shape of the curve is called as curve tracing. The approximation shape of the curve. Curve tracing. Curve tracing. The approximate shape of the curve is called as curve tracing. Now, curve tracing depending on the equation type. Now, there are three types of equations generally you can see. One is Cartesian equations, Cartesian equations. Second, parametric equations, parametric equations. And third is polar equations, polar equations, polar equations. Now we know everyone what is meant by Cartesian, what is meant by parametric equations. Even though I'll explain you. Equation containing x, y, z, these types of variable, then you can say it is Cartesian equations. Parametric equations. Now x is functions of t or y is functions of t or any parameters. Here t is parameter or x is functions of theta, r and theta, functions of r and theta, and here y is functions of r and theta. Means r is nothing but here a parameter, theta also parameter. These are the parameters, either in theta, either in t, either in r, any one, either not in both r and theta, either r or theta, either r or theta. Such equations you can call as parametric equations. Now, which equations are called as polar equations? Now we know polar form. Polar form means r and theta. Equation containing r and theta, then such equations we call it as polar equations. Polar equations. Now we'll go for one by one point how to discuss about all these points. Now first you'll go for Cartesian equations. Cartesian equations. Now there are important roles here how to trace the curve, Cartesian equation curves. How to trace the curve. Now Cartesian equation means either functions of in terms of x and y. Now there are some major points in the tracing. What should be check? In that first point is there. Now check symmetry. Symmetry of the curve. Symmetry about x-axis, symmetry about y-axis, or symmetry about the line y equal to x-axis, symmetry about the y equal to minus x-axis, or any other axis where the curve is symmetry or not symmetry. Now second is that whether the curve is cutting to the coordinate axis. You have to check it. Is coordinate axis is curve is intersecting or not? You have to check it. That is called as intersection. Second point is whether the curve is passing through origin or not. you have to check it. This is the originality condition. Third, C point, that is called as intersection. Intersection of a curve to the coordinate axes. Coordinate axes. Then fourth point, that is tangent to the curve. Tangentship. Tangentship, whether the curve is having a tangent or if tangent is parallel to axis or y-axis, you have to verify. The next point is the asymptote. Asymptote. Okay. Now asymptote is identify whether it is parallel to x-axis or y-axis or any other line. Then last point is the nature of curve. Nature of curve, we also call as absentship. Where the curve is absent and where the curve is existing, we have to identify from the equations. Now we go one by one points, discuss with deeply discussion about the one by one points. Now first we'll go for the first point, symmetry. Now we go for first point, symmetry of Cartesian equations. Symmetry of the curve about the axis. Now first point in that symmetry, you check powers of variables. Powers of variables, whether the curve is symmetric about axes, you can identify. Now even power of y indicate that the given curve is symmetric about x-axis. Symmetric about x-axis. Even power of y indicates symmetric about x-axis. Similarly, even power of x indicate that curve is symmetric about y axis. Now I'll explain what is my even power, what is meant by odd power. Now we have standard equations. Y square equal to 4x. This is equation of a parabola which is studied in 12th standard also. Now here these powers, this is y variable and this is x variable here. The power of y is here 2 and power of x is 1. Here the even power of y, after converting equation in terms of one variable, then here y is in terms of functions of x, means y is functions of x, and this y power have to check whether it is even or odd type. Now here y power is even. Y power is means y square equal to 4x. Y power is even. Therefore, the curve is symmetric about x-axis. Symmetry about this is our x-axis and this is y-axis. Symmetry means this is parabolic equations. Symmetry about x-axis. This is y square equal to 4x. Now, similarly, if the curve is given to you in another form, you can say it is x square equal to 4ay. X square equal to 4ay. Now here the powers of these two variables. Now we converted x equal to functions of y. Powers of x is here even number. X is even, therefore symmetry about y-axis. Symmetric about y-axis. Even power of x indicate that symmetry about y. Actually, this is symmetry about x-axis as well as y-axis. Now we go for third point, that is symmetry about both the axes, means even powers of both the variables. Suppose x also even power and y also even power. If index n is even number, n is even number. If both variables x and y are even powers, then the given curve is symmetric about both the axes. Curve is like this: x square plus y square equal to r square, equal to r square. Means here curve is symmetry about both the axes. How come? There you can write down like this also: x square equal to r square minus y square. Therefore the given function has a even powers, and or you can convert y square equal to r square minus x square. Therefore this is also function. Now here this function can be written as y square equal to variables. Therefore here y power is again even number. Then here symmetry about y-axis, symmetry about x-axis, means both the axis it is a symmetry. Now it's equation of a circle. We have equation of circle which is passing through center at radius 0 0, the passing through at radius a, circle center at 0 0, radius r. Like that we get the identification of whether the curve is symmetry about x-axis or y-axis. Now next case, D case. If you replace x by minus x, x by minus x, y by minus y simultaneously, if the equation does not changes, if the equation remains unchanged, if the given equation unchanged, given equation is unchanged, then you say that curve is symmetric in opposite quadrant. Okay, symmetry about opposite quadrant. Now what is meaning of this one? If you replace x equal to minus x and y equal to minus y simultaneously at a time, both one by one, then curve does not changes, curve remains unchanged, then symmetry about opposite quadrant. Now suppose this is here your x axis y axis. Now we always say it is first quadrant, this is second quadrant, this is third, and it's a fourth quadrant. Symmetry about the opposite quadrant. Now suppose here is your diagram, like this curve is there, like that curve is there. It's a reflection comes here in the opposite quadrant, this like this curve. Okay, suppose like that here is a question mark. It's a symmetry goes to here. Okay, question mark. Curve is symmetric here. Means these two are called as opposite quadrants, and these two are called as opposite of each other, opposite quadrants. Then curve is symmetry in opposite quadrant. Like this, suppose here curve is like this moving here. Suppose like this here curve is moving like this, then the curve also moves like this opposite quadrant. Symmetry about opposite quadrant. This is meaning to replace x by minus x and y by minus y, the curve is symmetric about in the opposite quadrant. We go for next point E. You go for next point E. Now if you replace x by y and y by x, then equation is unchanged. Equation unchanged. Curve is unchanging. Then we can say that curve is symmetric symmetric about y equal to x line, y equal to x line. This is very important. Put x equal to y and y equal to x. The given equation does not changes, then we say that the given curve is symmetric about y equal to x line or x equal to y line. Now, which lines we call it as x equal to y line and y equal to x line? Now, suppose here this is our coordinate axis. This is called as y axis, x axis. This is y axis. This is x dash, and this is y dash axis. The line which is passing through origin and making equal angle, means 45-degree angle with x axis. This line is called as y equal to x line, y equal to x line. Then curve is symmetric about y equal to x line. If you replace x by y, y by x, the curve or equation of a curve does not changes, then you say that the given curve is symmetry about y equal to x line. Now similarly, if you go for next conditions, if you replace x by minus y, interchanging and sign changing also, then y by minus x. Here directly there x equal to y, y equal to x. Now sign change also, variable also change. X is changing to minus y, y is changing to minus x. Then the equation of a curve does not changes. Equation of a curve unchanged. The equation remains same. Then you say that the curve is symmetric about the line y equal to minus x. Symmetry about y equal to minus x line. Now where is y equal to minus x line? The same diagram I will show you. And suppose line here is there in the second quadrant and fourth quadrant passing. This is called as y equal to minus x line. Symmetric about this line. Symmetric about this line. Symmetry means suppose here like this curve is there or this triangle. Then you get here same like here, this like a triangle which is symmetry both side. Symmetry on both side. That is called as symmetry about y equal to minus x line. This is about all symmetries. I repeat all once again. We'll go back to all one and I'll explain you all this symmetry within short period once again. Now symmetry x-axis symmetry, y-axis symmetry. Okay. Opposite quadrant, symmetric about y equal to x line, symmetric about y equal to minus x line. When you say that, the curve is symmetric about these lines. Now symmetric about x-axis means even power of y. This is symmetric about x-axis, and even power of x means symmetric about x-axis. Symmetric about x-axis. Opposite quadrant means x is replaced by minus x. X is replaced by sign changing. X is changed to minus x. Y is changed to minus y. Then you say that the given curves are symmetric about in opposite quadrant. Next, when you say that the curve is symmetric about y equal to x line, then x is replaced by minus x is replaced by y, and y is replaced by x simultaneously. X is replaced by y is replaced by x simultaneously. Then curve remains unchanged. Then you say that the given curve is symmetric about y equal to x line. Now when you say that y equal to minus x line is curve is symmetric about this line. If you replace x by minus y and y by minus x simultaneously, the curve remains unchanged. Then you say that symmetry about y equal to minus x line. I'll just show you nature of the curves, how the curve looks by these symmetries. Symmetry about even powers of y, symmetry about x-axis means like this. Curve is symmetric about this curve. This is x-axis. X-axis, both side curve must be same symbol. Symmetry about y-axis. Suppose this is your y-axis. Suppose this is our y-axis. Now like this curve is there. Suppose like this curve is there, and you get symmetry about means this side also you get same like the curve. Symmetric about y-axis. This is y-axis, x-axis. Now here replacing x equal to minus x, y equal to minus y, opposite quadrant symmetry. Now suppose here, now you got a curve like this here. You got a curve here. Like this you got curve in one quadrant. So it is first quadrant, which is similar to that same loop into the opposite quadrant. That is nothing but third quadrant. Okay, then you say that curve is symmetric about opposite quadrant. Now same like here, suppose here is a like this angle, and you get here also like that angle, which is symmetry about opposite quadrant. Now what about y equal to x line? Suppose here our coordinate axis is x equal to y line means like this here, a line passing through origin, and symmetry about this one. This line symmetry means suppose you got here a loop, same loop also get this side. Okay, this line, suppose here you get this one curve, like that you also get this side curve. This curve is symmetry about this y equal to x line, x equal to y line. And last one, then when you say that curve is symmetric about the other line, y equal to minus x, then here it's in second and fourth quadrant. Curve is symmetric in the means line passing through origin and divides both the quadrants second and fourth equally. That is called as y equal to minus x line. This is our curve, and curve is symmetric about this line. Suppose you get here a curve, like that you get same curve this side. This also same curve. That is called as symmetry in a y equal to x line. Now you understood what is meant by symmetry. Now we'll go for the next point, how to construct these points or these curves in a shortcut ways. Now next we go for second point. Second point is origin. Check whether the curve is passing through origin or no. Whether the curve is passing through origin or no. How to check it? Now put, if the curve does not containing a constant term, then you say that the curve is passing through origin. Means no constant, absence of constant term, no constant term in the equation. Then you say that the curve is passing through origin. Or one more method is there to check whether the curve is passing through origin or not. You put x equal to 0 in the equation, you have to get y equal to 0. Put x equal to 0 in the equation, you have to get y equal to 0. Or vice versa, if you put y equal to 0, you have to get x equal to 0. Means by putting x equal to 0, y also have to get 0, or by putting y equal to 0, x also has to get 0. Then you say that the given curve is passing through origin. Got it? Now we go for next point. We'll go for next point, whether the curve is intercepting the coordinate axis or no. Let's check intersection of the coordinate axis. This is called as interception. Intersection of the curve with coordinate axes. Coordinate axes. Coordinate axis is simple here. If you put x equal to 0, we have to get some value of y, some value of finite value. You can say finite value of y. Then you say that curve is intersecting x-axis, y-axis. Curve is intersecting y-axis. This is called as y-intercept. Where the curve is intercepting y-axis. Y-intercept. Y-intercept. And similarly, put whether the check whether the curve is intercepting x-axis or no. Then put y equal to 0. Put y equal to 0. And x must be get finite value. You have to get x must be finite value of x. Then you say that the curve is intercepting x-axis. Curve is intercepting x-axis. Now suppose here x-axis and y-axis. Now our curve is like this going on. Here is suppose curve is like this going. Means here this point and this point are the point of intersection of our curve to the coordinate axes, whether the curve is cutting or not cutting. Now here some value of x, means say xi, and y must be 0. Means by putting y equal to 0, we get some value of x. Then you say that the curve is intersecting x-axis. Curve is intersecting x-axis. This is point. Now suppose this point is here. Here x is 0 and some value of y, finite value of y, then 0 y. Any point on this y-axis is 0 y. And if you get like these options, either this or this, then you can identify our curve is cutting coordinate axis at that point x0 or 0 y point. Means this is called as coordinate interception method. How to find out whether the curve is intersecting or no. Now after that we go for the next fourth point. You go for the fourth point is asymptote. Asymptote, so many students get confusion between asymptote and tangent. Okay, asymptote and tangent. What is meant by asymptote and how to get the asymptote is a straight line which gives you nature of curve at infinity. Nature of curve at infinity. And this curve is extended up to infinity. This curve never intercept our curves, or this line asymptote is a line which never intercepts our curves. Or asymptote is a line which gives us at infinity also nature of the curve. It is near to curve but not intercepting the curve. This is asymptote equations. Okay. Now after the asymptote we will go for next point, fifth one. And how to find out? Suppose here sometimes you ask you how to find out the equation of asymptote. Equation of asymptote. Now convert equation either x equal to f of a upon f of b, f of b or y or f of y upon f of y, y1, y2. Now put denominator equal to 0. This denominator equal to 0. That gives you equation of asymptote. Equation of asymptote. Denominator equal to 0. Then you get equation of asymptote. Next point is tangent. Next point is tangent. Now we have usual method how to find out equation of a tangent. Equation of tangent means suppose you are given function f of function is given to equation is given to f of xy equal to 0. This is the equation given to you. Find out dy by dx, dy by dx. Now where you get the finite values or equation, dy by dx are in the range. In the range means where the value of x and y are existing. That point you take, suppose x1 y1 equal to x1 y equal to 0. If this you get equal to 0, then tangent is parallel to x-axis or itself. Just I'll go to next slide, then you'll explain what are these conditions, how to identify the tangency. For any equation xy equal to 0, first find out dy by dx, dy by dx. This is nothing but tangent. Now whether tangent is parallel to x-axis or y-axis, dy by dx equal to 0 at any point, then you say that the tangent is parallel to x-axis or itself, x-axis itself, x-axis itself. If dy by dx is equal to plus or minus infinity at any point, say x1 y1, then you say that the tangent is parallel to y-axis or y-axis itself, Then if dy by dx is greater than 0, this indicates that given curve strictly increasing curve increasing means slope is increasing, like this curve is there, curve is increasing, slope is positive, increasing curve means like this curve goes, this x-axis and y-axis, curve is increasing means going upward directions, increasing. Similarly, if dy by dx is less than 0, then given curve is strictly decreasing in nature. Curve is decreasing in nature. Okay, this is the tangency. Now one more shortcut method is there, how to identify the tangency or equation of a tangent to the curve. Now once you got these are the equations, y minus y1 equal to dy by dx into x minus x1. This is one of the way to calculate equation of a tangent, to the curve at a point x1 y1, x1 or y1, particular point only. Okay. Now second shortcut method to how to identify the equation of a tangent. Now convert given equation either y equal to f of x or x equal to functions of y, depending on our equations how they are given, even powers or odd powers when you calculate. Now the lowest degree term of the numerator or of the equation equate the lowest degree terms of the equations, you get equation of a tangents. Or given equation, suppose you have converted y equal to functions of fx upon again fx or gx, this function type. From the numerator, find out which is the lowest degree term, lowest degree term and put equal to 0. From the numerator, lowest degree term, put this equal to 0, you get equation of a tangent to the curve. Equation of a tangent to the curve. Now next last point is that absence of the curves. This is how to identify the given curve is a real curve or imaginary curve. Now if after the calculating values of this one, you get a range of the values a or b, x equal to a or b, or y equal to c or d, the range. In the range where the curve is absent or present, you take 0 is less than x less than a, depending on the equation of curve. Put any value of x in between 0 to a. Suppose you take a by 2, x equal to a by 2, means here you get some other point. Put this value of a by 2 in the equation of y and get value of y. If y is a real number, then we say curve is existing here. Y is a real number, curve is existing. If y is imaginary, then no curve existing. Curve is absent here. No curve. Here curve is absent. Curve is absent here. Got it? Now similarly, if you got y value functions of x, and by putting value of y in the equations or x value in the equations, if y gets imaginary, you say that curve is absent at that range. Now suppose x, I'm talking about x in between 0 and a, and next point we're starting a, x between b, and next b less than x less than any infinite value or any other values. Now by putting value of x any in between a and b, if check value of y is, or it is finite value or no finite, means infinite value. No finite value. No finite means absent. Curve is absent here and curve is present here. You can construct here. And between here, you take in between a and b any point. Suppose if I take x equal to 3a upon 2. 3 upon 2. 3a upon means above a, below b. You take any value of x. And by this value of x, if y gets, again same, if y get finite value, then you say that curve is existing, or y not get finite value, then you say that curve is absent in between. Similarly for b, if you take any point of x which is above b, then you can say that the curve is existing or not existing. Similarly, this is for x. Same, suppose if you have value of y, you can check y also, whether the curve is existing or not existing. Suppose you got c is less than y less than d. You take any value of y in between c and d, or 0 to c, or d to any other values, like that 0 to y up to c, in between 0 to c, or in between c and d, or above d. Y have to get above d. Then same again, put value of y in the equation. If x gets finite value, then curve is existing, and x you get infinite value, means no finite value, You say that no curve, absent the curve between this one. Okay. Now this is a simple concept to identify the curve is absent or present. Now we'll go for simple example. We go for simple example how to find out the curves are whether these are existing or not. How to find out the corresponding points. Now we'll go for one example. Consider one example. First example, you can say. Now suppose trace the curve. Trace the curve. X into x square plus y square is equal to a into x square minus y square for all value of a greater than 0. This is given equation. Now check how to identify these curves. Before going for this one, no examples, you have to make in our mindset. We are going to check symmetry. Symmetry. Second point, we are going to check whether the curve is passing through origin or no. Third point, we are going to check intersection, means coordinate intersection. Fourth point, we are checking tangent. Fifth point, we are going to check asymptote. And sixth point, we are going to check whether the absence of the curve. Whether the curve is absent or present during the intervals. Now, before explaining these points, to go for first, the given equations have to rewrite in the proper way. Now here, copy the equation properly. X into x square plus y square is equal to a into x square minus y square. This is given equation. X into x square. This is x into x square. Multiply inside. You get x cube plus x y square is equal to ax square minus ay square You can see here also y square is there and here also y square is there and here x cube is there and here x square is there. X cube and x square. Now take both the y square one side. Now you can see here the powers of y's. Here is 2 and here also 2. That's why we are taking one side. Now take this side, x plus a into y square equal to remaining terms to the side, ax square minus x cube. Ax square minus x cube. This is one term. Now here y square is there. Keep y square one side. The remaining term must be shifted to other side. X square minus x cube divided by the terms which is the coefficient of y square, x plus a. Now this also can be written as like this here. X square you can take common outside from the numerator. A minus x upon x plus a. This is our equation. Now for this equation, we are going to modify or verify the given curve is symmetry or not symmetry. Symmetry about which axis. Okay, this is equation of a curve. Now carefully you have to observe it. Okay, how to get. Now this is y square. Means you got here even power. Even power of. I'll go to next slide. I'll write just one second equation. Y square equal to x square into a minus x. X square into a minus x divided by x plus. This is our equation. Now we are checking. Now here we got given powers. First point to get symmetry. write points wise symmetry. Even power of y indicate that curve is symmetric about x-axis. Curve is symmetric about x-axis. This you get first point of symmetry. Once you identify the curve is symmetric about x-axis, symmetric about x-axis, you can check all the possible cases. X symmetry, y symmetry, replace x by y, y by x, curve remains unchanged. That matter all things. Okay, symmetric about x-axis. Now second, you check origin, whether the curve is passing through origin or not. Check whether the curve is passing through origin or no. This is second point. Now how to check the curve is passing through origin or not? Now just I told you, put x equal to 0. Check whether y is getting 0 or no. If y got 0, then say that curve is passing through origin. Now if x equal to 0 here, 0, see 0, 0 into something is 0, then 0 upon 0 also 0. 0 upon something is 0, means you get y equal to 0. This indicates that curve is passing through origin. Curve is passing through origin. Similarly, we check if you put y equal to 0, y equal to 0, then x also get 0. X also get 0. Therefore, again you can identify the curve is passing through origin. Now next point, how to identify whether the curve is intercepting coordinate axis. Coordinate axis, intersection of the curve with a coordinate axis. Similarly, put x equal to 0. Put x equal to 0 means y you got 0. This you get 1.00. Means curve intersecting x-axis as well as y-axis also, both at a 0, 0 point. Both at a 0, 0. Similarly, we put y equal to 0. Find out the value of x. How many values of x you get? Means y equal to 0 means you get x square upon a minus x upon x plus a equal to 0. Okay, then you get x square a minus x equal to 0. Means x equal to 0 you get 2 times, x equal to 0 you get 2 times, and you get x equal to a point. X equal to a point. 0, 0 means curve intercepting y-axis. Okay, these 3 points means 0 and 0, then a and 0. 0, 0 2 times means curve is taking loop on that coordinate axis. Okay, loop means passing through same origin, again returning back to back again origin. That time curve is passing through 0, 0. Okay, this is the one of the simplest method to identify whether the curve is passing through or intersecting coordinate axis or not. Now next, we will check whether the curve is tangent or not. Tangency. Okay, tangency. Just I told you, please. First, rewrite the example in the proper way. Then y square equal to, we got x square into a minus x upon x plus a. This is our equation. Now here you get 2 equations at a time. To find out equation, the lowest degree term in the numerators or in the equations throughout the equations. This is lowest degree term in the numerator. Lowest degree term means equation number tangent. Equation number tangent is equate the lowest degree term equal to 0. Means x equal to a. X equal to a. Equate the lowest degree term in the numerator equal to 0. That you get equation number tangent. This is equation number tangent to the curve. Means a minus x equal to 0, and this equation you get x equal to a. This is equation number tangent to the curve. I'll repeat once again. The lowest degree term of the equations equate or make it equal to 0 if you converted one side. Then you say that equation of a tangent. Similarly, you get here equation of asymptote also. Equation of asymptote. Asymptote means again here put diameter equal to 0. Put diameter equal to 0. I'll take this is your diameter. This diameter equal to 0. Then you get asymptote. Asymptote diameter equal to 0. Here lowest degree term in the numerator equal to 0. Now lowest degree term equal to 0 means here x plus a equal to 0 and x equal to minus a. This is equation of asymptote. You got asymptote, you got equation of tangent, you got where the curve is passing through, origin or no, and this all things. Okay, equating this is equating this all. Okay, now how to get equation is tangent to the curve at a lowest point, and similar way to make the given equations you have to find out equation of a tangent to the curve at that point. Now origin of absentee. Next is how to identify absentee, origins of the absentee. Now here origin of the absentee. Zero is less than x less than a. X is above a means 0 is less than x less than minus a, or x is greater than a, or x is less than minus a. These are the ranges. Why? Asymptote you got. No, here asymptote. That's why you got asymptote. We got how to identify this one by using equation of asymptote as well as asymptote equation. You got x equal to plus a equal to 0 and x minus a equal to 0. This equation of tangent means here you get x is minus a also, x is plus a also. By using this one you have to find out absence of the curves. Okay, now check. You take in between. First point you take 0 is less than x less than a. You take any point between x equal to between 0 to a. Then you take x equal to a by 2. X equal to a by 2 in the given equation. Now you put given equations, you get y positive value. You get y positive value means curve is existing here. Now similarly, if x is greater than a, you take any point of a. You took x equal to take to a. Then check the value of y. And y you get here imaginary value. Therefore, this shows that the curve is absent for in the range above x equal to a. Now again, you take any values x equal to minus a. This is our asymptote. Below asymptote, we must get our curve. Okay. Then we get above a minus a less than x. Okay. Then our curve is this side only. This side only. Curve cannot cross our asymptote. Okay. Now how to construct actually? How to construct actually? Now we got all the points. First list out the points. What you got? We got origin 0 0. Also curve passing through 0 0. And we got one more point a 0 point, 1 0 point a 0 point, x equal to a, y equal to 0 intersecting the axes, and we got x equal to minus a asymptote line, and x equal to a equation of a tangent to the curve passing through. Now how to construct a real? Now make it x-axis. Now it's a y-axis, x-axis, y-axis, y-axis. I'll use different color for the curve. We got a point where the curve is passing through, and also curve is passing through a and 0, x equal to a, y equal to 0, and one more point you got the x equal to a point. This is x equal to. Now here same exactly distance here. We get here this point. This is minus a and 0. Means x equal to a line, means a line which is parallel to y-axis passing through a line which is parallel to x-axis and passing through this one. Here you get a line which is passing through a point, that is here point a0, minus a0 and a0, where the curve is existing. Now this is our asymptote. This is asymptote. Asymptote curve means we never cross this side. Okay. Now if you want to take more than 2-3 points where your curve is asymptote, means curve never, and this point we got 2 times. We got 2, means our curve is passing through 2 times this point, y equal to, our curve is passing through 2 times at origin, means this origin point 2 times going. Again curve is passing through a0 line also. Symmetry about x-axis. Symmetry about x-axis means this curve is passing. Symmetry about x-axis means whatever the curve is there on the above the x-axis, it must be there here also. Then I'll reconstruct it properly. Means curve is passing through a0 point and passing through origin and moving this side. Passing through origin and moving this side. Both sides must be curve pass. You cannot cross this asymptote line. You cannot cross this. This is x symmetry passing through a0, passing through 0 also. This is equation. Okay. Tangent to the curve at x equal to f. X equal to f, and you can calculate so many tangents to the curve at any different points. Now suppose you got here equation like this: y square equal to x square into y square equal to x square into a minus x upon x plus a. This is our equation of a curve. You can equate both sides the equal powers. Means x into y square plus a into y square equal to ax square minus x cube, equating lower powers. Okay, you get the values. Then y equal to plus or minus x square equal to y square, you get x square equal to y square, this you get cancels, then you get a plus or minus x. This also equation of a tangent to the curve at that point. Okay, understood what is the curve tracing? Like that you can trace the curves. First identify the all the values. Now here we stop here only, then for the next point you can come to the